My name is Ray Durrheim. I'm a professor in the School of Geoscience at the University of the Witwatersrand in Johannesburg. Now, my research area is geophysics. Geophysics is where you bring together the study of the Earth, its size, its shape, what it's made of, how it formed, how mountains are built, how ocean basins are formed, and also using the methods of physics. Those are things such as the Earth's gravity, its magnetism, the way in which electrical currents flow through the Earth, the way in which vibrations move through the Earth, to find out more about it. And this science is used to do things such as find new mineral deposits for energy, or for resources of oil and gas, of metals such as iron and manganese and platinum and gold and coal, and also to study things such as geohazards, things that cause harm to people, such as earthquakes, volcanoes, and landslides. Well, I grew up in Cape Town, did all my schooling in Cape Town, and I guess I'm one of those fortunate folk that both had an aptitude for maths and science and languages. So I did, in fact, very well at school. I suppose I grew up in a family. Both my parents came from farming families, and so we'd often, for our holidays, go back to the family farms in the Eastern Cape, and also have many holidays along the beaches or in the mountains. And so it's something I think I also just took to naturally, just enjoying being out of doors, being at the sea, in the mountains, in the rivers, and exploring. I needed to look for a bursary, and I was fortunate to get a very generous bursary from a mining company that was called General Mining. And even to this day, many mining companies, of course, are looking for skilled practitioners, for geologists, for mining engineers, for geophysicists. If you look around the room that you're in, you'll find that all the materials around you are either mined or they are grown. Now, you'll see there, of course, bricks and concrete are made from earth materials. If you see things made out of plastic, well, plastic, in fact, comes from petrochemicals, from hydrocarbons that come out of the earth. You see motor cars, of course, are made out of steel, and so that comes out of the earth as well. So the earth materials are absolutely crucial to modern society. Even your cell phone is made out of many materials that are mined. The glass, all the special elements that are used to make the transistors and electronics work. And so that's been something that really drew me to the science of seismology, is to look at the great forces of nature, earthquakes. And our South African mines are like earthquake laboratories. We can do research here that you cannot do elsewhere in the world, because it is our mining process over here that triggers these earthquakes. So we know where we are mining, and we've got a fair idea where the next earthquake will be, and almost when it will happen as well. So that allows us to put instruments into these in the mines, study the way in which the earth responds to the mining, see the way in which the elastic forces build up inside the rock. It's a bit like if you imagine if you had to take a plastic ruler and bend it, and you'd see little cracks appearing, but at one stage there are too many cracks, and suddenly that plastic ruler will break. It's the same with a rock. Your rock gets damaged and energy is stored up, and then at some stage the rupture occurs, it zips through it, all that energy that's stored up makes the ground shake, and that can cause rocks to be ejected, the roof to fall down, and that's a very significant hazard for mine workers in our deep mines. Here at WITS we have a research group which we call the WITS Integrated Mining Health and Safety Research Group, which I currently am chairing. But these are people who are working on mining, but from different aspects. And so you find that of course there are geoscientists and mining engineers, that's obvious, but you also have mechanical engineers and chemical engineers and metallurgists. But you go further afield, you find people working in public health, looking at occupational disease. You find people working as biologists and looking at ways in which we can prevent pollution and we can remediate areas which have been damaged by mining. We even find people in fields such as law who are involved in this, because we need rules and regulations to govern mining and to issue mineral rights. And you find people even in things such as sociology, because you're working with large workforces. I'd say that I'd encourage you to really be curious about things. When you look around you and see a mountain or a river, ask, why is the river there? Why did it choose that course? Why is that mountain there? And in this way, and dig into the internet or look in books, use atlases, learn to read maps. And when you are walking out in the veld, pay attention to the soils, to the rocks that you see, to the vegetation that's growing there, and try to see what sense it and make sense out of it. And that's really the kind of curiosity that we need to be a scientist. I mean, I think for us as earth scientists, we have an incredibly important role to making sure that we preserve our planet for my children, my grandchildren, and for your children as well. And so that involves being responsible in the way in which we mine, in which we dispose of our waste, in which we reduce the amount of carbon dioxide we pump into the atmosphere. And that is a very important role in future for geoscientists, is to be involved in these environmental issues.